Hi Rangers, this video is the intro to systems. So starting off with a word problem, Jules opened a checking account with $500 and plans to spend $50 each week. Astrid opens a checking account with $50 and plans to save $25 each week. Write an equation to show the relationship between the account balance Y and the number of weeks X for both Jules and Astrid. So we're going to start off with writing an equation just for Jules. So again, Jules opened a checking account with $500 and plans to spend $50 each week. Well, this tells us a lot of information, but first remember that we have y equals mx plus b, where m is our slope, b is our y-intercept or our initial amount. So in this case, our initial amount is $500. So we know y equals $500. And then she's planning on spending $50 each week, which makes that our m. And since we're spending, it's a negative 50. So I have 500 minus 50x. Okay. Then I'm going to write an equation to represent Astrid. So Astrid opened a checking account and with $50 and plans to save $25 each week. So my initial amount is $50 and I'm saving, or she's saving, $25 each week. So that's going to be a positive number. So we get y equals 50 plus 25x. Now, what we're going to do is I'm going to show you how to type these into the calculator to get the table. So we're going to start with typing in Jules, and then we're going to record her table below. Okay, so we're going to go to our graphing calculator. We're going to go to a new graph this time, and we're going to type in her equation. So it was $500, and she's spending $50 each week. So there's our equation. There's the graph for it. So it doesn't show, which is perfectly fine because we just need to look at the table. So for the table, you're going to hit Control, the yellow button, and the letter T for table. Control T. You can also go to Menu, Table, Split Screen Table. And all we're going to do is we're going to write down these numbers or these values into our table. So at 0 weeks, she has $500. Change my pen color. Oh, nope. Okay, we'll stick with blue. So we have $500. At 1 week, she spends $50. So we're down to $450. Then we have $400, $350, $300, $250, $200, $150, $150, and after 10 weeks she has $0. Okay, now I want to write or fill in the table for Astrid. So I'm going to move this over. I'm going to go home, discard my changes, and I want a new table. Okay, you never want to save, so if it asks you to save, never save. Okay, and we have y equals 50 plus 25x. Okay, again, we're going to go Control, the letter T for table, or Menu, Table, Split Screen Table. And now we have the table for Astrid. Okay, so starting at 0 weeks, she has $50. And then we have 75, 100, 125, 150, 175, 200, 225, 250, 300. Oh, I skipped one, 275. So there we go. Oops. 275 and 300. Okay, so now I'm just going to go back to my notes page. Okay, so now I have the table, Now I'm going to graph each girl's table. So I start with 0, 500. So 0, 500. And then it's 1, 450. 2, 400. And you have to pay attention to the scaling because my y-axis is going by 50s. 3 would be 350. 4 is 300. 5 is 250. 6 is 200. 7 is 150. 8 is 100. 9 is 50. 10 is 0. Now that I have all my points, I'm going to connect the dots. Okay. Then I'm going to fill in or graph Astrid's table. So I'm going to zoom in a little bit. Now, this one, I'm only going to graph the ones that are in increments of 50 because of the scaling on the graph. So those are the numbers I'm going to graph because I don't want to have to guesstimate where 75 is. I can, but I don't really want to do it. Okay, so I have 0, 50. Then I'm going to go to 2, 100. Then I'm going to go to 4, 150. Then I'm going to go to 6, 200. 8, 250. And 10, 300. And I'm going to graph them. Oops, that was a really bad line. Okay, now that we've done that, what do we notice about the lines graphed? Okay, we should notice that they both intersect right there. This is known as the point of intersection. Okay, right here where these two lines intersect. Change it to purple. Okay, what is that point? Well, I go over 6 and I go up 200. So where does the graph lines intersect? At 6, 200. Okay, now what do you notice about week 6 in the tables? Well, week 6 right here and week 6 is right here. Notice that they have the same ending balance. So that's what we're going to say. Okay, so what I want you to do right now is I want you to pause this video and try to work out the next example on your own. If you have any questions, please make sure you ask your teacher, and you can check your work with mine after you unpause the video. So go ahead and pause the video now. Okay, so I'm going to go ahead and just work through this. Again, if you have any questions, please make sure you reach out to your sister, your teacher. I need to go to bed. Here we go. So there we have the mouse arrest charging $125 and then $25 per month. So my $125 is B, my M is 25. So my equation is y equals 125 plus 25x. Okay, then we have Hugs Not Bugs, is just $150 per month, okay, which is my M, and that's all the information. So in this one, there is no B. So I just have y equals 50x. I'm going to go ahead and fill in the table. Hopefully you graphed it and looked at the table yourself. So we have 125, 150, 175, 200, 225, 250, 275, 300, 325, 350. Okay, since I have that, I'm going to go ahead and graph. And this time my scaling's a little different, so I can go by 25s. So I'm starting at 125 here. And then it is 150, 175, 200, 225, and 250. So I have this here. Okay, now filling in the table for the hugs not bugs. So I have 50, 100, 150, 200, 250, 300, 350, 400, 450, and 500. Okay, so I'm going to start by plotting that. 1 is 100, 2 is 150, 3 is 200, 4 is 250. Okay, so I connect my dots. Ooh. Okay, so what do we notice about this? Again, it has a point of intersection. This is also known as the solution. Point of intersection and solution are the same thing. Okay, so it is intersecting at 3, 200. Now, the important part, what does this solution represent? Okay, I do not want you to just say point of intersection. We know that, but in this situation, what does it represent? Well, it tells us when the cost for both companies are the same. So after 3 months, both companies will be charging, or at 3 months, both companies will be charging the same amount. Okay? But if it is more than 3 months, then Hugs Not Bugs is more expensive. If it's less than 3 months, then it's cheaper. So it's important to know the difference and see that. Okay? Moving on to the next part. A system of equations is 2 or more linear equations that use the same variables that forms a system of equations. Okay? Notice that for both examples, we had 2 equations, y equals, okay, 2 linear equations. That is a system, having 2 or more linear equations. Okay, a solution of equations is the solution of a system of linear equations is the ordered pair that makes all the equations in the system true. Okay, so if I were to plug in our answers that we got, this 3, 200 and this 6, 200, into this system, into both of these equations up here and both of these equations here for the respective values, in the calculator, we would get true statements. And I'll show you what that looks like in the examples below. Okay, but just know it's going to make them true. And then when a system of linear equations is graphed, the solution, okay, the solution to the system can be found by looking for the point of intersection. Okay, the point of intersection. Those are the same thing. So solution and point of intersection are the same thing. So what we're going to do is we're going to graph this. You can graph it using the calculator and table. I'm going to graph it by hand. It is your choice. And then I will show you how you can check your work. Okay, so first off, we have M is equaling -1, B is equaling -2. So I'm going to start here at the y, or on the y-axis. My slope is a -1, so I'm going to go down 1, right 1, down 1, right 1. And I'm going to keep continuing that pattern. Okay, you need as many points as it takes so you can clearly see what the point of intersection is. Okay, once I feel like I have enough points, I'm going to connect my dots with a line. Then I'm going to graph the second one. My M is 1/2. My B is 7. So I'm starting at 7. I go up 1, right 2, and I run out of space. So I'm going to go down 1, left 2, down 1, left 2. Again, I'm going to keep continuing this pattern until my 2 lines intersect, so I can clearly see what my solution is. So this tells me right here, oops, my line is really off. There we go. Okay, right here is my point of intersection. This point is -6, +4. So how we can check this is using our calculator. Okay, so how we use our calculator is we're going to plug in -6 for x and 4 for y. So I have 4 equals minus a -6 minus 2. And I'm going to go to my calculator and type that in. So I'm at my calculator. I'm going to go home. No, I don't want to save. New calculator this time. Okay. Let me put my notes on top so we can see. So I'm going to type in 4 minus a -6. Oops. Sorry. 4 equals minus a -6. There we go. Don't forget that equal sign. Minus 2. I'm going to press enter. When I move my paper out of the way, it says true. We get a true statement, which means it works in the first equation. Now we got to do the same thing, but for the second equation. So we have 4 equals 1/2 times -6 plus 7. So now I'm going to type that in. So I have 4 equals 1/2 times -6 plus 7. And when we do that, we get another true statement. And so we just proved and checked our work that the point we got as our solution works in both equations. Okay, so let me go back to just the notes. Okay, so here we go, doing it again. We have y equals -5. So when we see that there's no x, we automatically need to think of Hoy Vux. In this case, it is a Hoy problem, which means it's a horizontal line with a 0 slope, and it's going to go through the y-axis at -5. So here's -5 on the y-axis. I draw my horizontal line through, just like that. Then I am going to graph my second line, where my m is -2, my b is -3. So I'm going to go down to right 1, and that's enough to see where they intersect. So for this one, my point of intersection is 1, -5. Okay, again, to check my answers, I plug in 1 for x, -5 for y. So for the first one, I would have -5 equals -5, which we don't need to type that in the calculator. We know that's true. And then the second one, we have y, oops, sorry, not y. Instead of y, we have -5 equals -2 times 1 minus 3. Well, we know -2 times 1 is -2, and -2 minus 3 is -5. Again, if you needed to, you could type that in the calculator. It would tell you that it's true. So we checked our work. Okay, last but not least, we want to know which of the following represents the systems of equations below. We can graph these and see which one matches or see where they're going to intersect. Okay, so we're going to go back to our calculator. we're going to go home, discard my changes, and we're going to go to a new graph. We can actually graph two lines at the exact same time. So I'm going to put my notes here so I can see my two equations. So in F1, I'm going to type in negative x plus 6. And then I'm going to hit the down arrow one time so that I see F2. And now I'm going to type in 2/3 x minus 9. And I'm going to hit enter. And I should have a red line and a blue line. Okay, a red line and a blue line. So by looking at where they intersect, just by looking at the picture, it helps me to eliminate answer choice A and answer choice B. So I'm going to zoom in on A so you can see it better. Notice that it's intersecting on an x-axis, and our picture is clearly not doing that. B, it's clearly intersecting in quadrant 1, and ours is down in quadrant 4. If we look at C and D, they're both in quadrant 4. We just need to confirm the actual number where they're intersecting. Okay? So to do so, we're going to look at the table. So again, Control T for table, or menu table, split screen table. And we want to see when this column and this column match up. It happens to be at 9, -3. Notice that the y values for both of them are the same when x is 9. So I want to check for 9, -3. That one seems to work. Let's see. 1, 2. That one's a little off. Okay. But how we can also check this out. Okay. Because those are really close and they look like they're intersecting at the same one. I would say that this one's a little off, but let's be double sure. Okay. And check the slopes of these two lines. So the one that is at 6, okay, my y-intercepts at 6 is right here. I'm going down one, right one. So that works out. Okay. The second line that starts at -9, -9's right here. I'm going to go up 2 and right 3. Up 2, right 1, 2, 3. Well, this one works out here. Okay, let's check D. Well, if I notice, D is not starting at 6 over here. So it does not work if we checked by knowing the y-intercept and the slope. Okay, so sometimes the graphing doesn't always do it the best, but you have lots of options because you have lots of tools in your toolbox. So if you have any questions, please make sure you ask your teacher, and don't forget to write your summary about this lesson.